Hi there, this is Peter from the Calva team. Today I want to show you some interactive programming again. This time using Clojure, Membrane, and a library from Babashka called Babashka FS, which has functions and stuff for doing something with the file system. So it's great. Membrane is the main thing we're going to use here, which is a simple UI library that runs anywhere. And we are going to use a very tiny slice of Membrane. We are going to use it only for actually composing an image, and that's something very overlapping with that and composing UIs. So I guess that's why Membrane is such a good fit. We're not going to dive any deep into Membrane, Babashka, or anything. We're going to focus on interactive programming using this project. I'm going to try to make it so that you don't have to have been using Clojure before to understand the thing with interactive programming watching this video. Let's see if I succeed. So the problem we are going to solve is that Twitter has removed the article information from link previews when you post links. This is how it looks now. This is actually someone who complains about this. And zoom in a bit maybe. So you see there is no information here about the title of this article or the description or anything. So you just see an image about on Elon Musk, and yeah, could be about anything. So we want to reclaim this information. So we're going to put it on the image, which they are still showing, like on X. So we're putting the information there as an overlay in the image, and so that's I've been doing this for the Agical blog, and this is a short usage how you do this. It's actually, if you know Clojure, it's this. If you don't know Clojure, don't have Java installed, then you have some few steps that you going to need to do, and you have some knowledge gaps you need to plug as well. And I'm going to try to plug them for you during this video. So we're going to do this using Calva, of course. I have the project here in VS Code, and I have Java and I have Clojure installed. And I also have Calva installed. Improve it here. So now this README here tells me that we should open this project. I've done that. We should start its REPL and connect it to the editor. So the way you do that in Calva is that you press this REPL button down here. The REPL button has appeared here because Calva sees that this is a Clojure project. So then Calva activates and shows you this button. And from there you should say, start your project with the REPL and connect. So it's doing both these steps here. And you should select Depths Eden from this list, because this is the Depths Eden project. Now the REPL starts, and we can hide this for now. The next step here is to open this file. So we can click it. This is the file. And it says that we should continue following the instructions in there. And the instruction here is to load this file in the REPL. So the way you do that in Calva is that you, in the command palette, you find Calva load and evaluate current file and its requirements. So we do that. Now that is done. And what has happened now is that it has evaluated all these forms here on the top level. So this NS form is evaluated. This function definition is evaluated. This function definition is evaluated, and so on. And also this comment form is evaluated. But the comment is a macro that doesn't include anything. So the result of evaluating a comment form is that nothing happens. regardless of what's in that comment form. So that's why we can use this place here as this playground. Because at the top here you see, then use the playground rich comment form at the bottom as well. So we call these the rich comment form because they are rich and because rich-seeking. So none of these forms have been evaluated. So if I try to evaluate this original path symbol, and the way to evaluate just one form in Calva, let me show you first how to evaluate a top level form. So this is this definition here. It is already defined, and since this is a literal, we see exactly the same thing here as it. But if we want to reevaluate this for some reason, we press Alt+Enter, and that will evaluate the top level form. And top level is the forms that are enclosed in white parens or white brackets in this case. So if we want to evaluate this, we place the cursor somewhere in there and we hold down Option and press Enter. And that's the way we evaluate top level forms. If we want to evaluate just this 0, for instance, it will evaluate to itself. Then we place the cursor somewhere inside it or beside it and press Ctrl+Enter. So now hold down Ctrl and press Enter, and that evaluates the 0. And you see it evaluates the 0, it evaluates to itself. And this 0.5 evaluates to itself as well. And this vector evaluates to itself as well. Ctrl+Enter is what I do when I evaluate just one form. So inside a rich comment form, like this one, we can evaluate these forms, the blue things, because they create a new top level. You're also using this Alt+Enter. But just to show you that this hasn't been evaluated, I will press Ctrl+Enter on original path here. And then we get the syntax error that original path can't be resolved as a symbol on this namespace because it hasn't been evaluated, because Clojure has only evaluated a comment form, and as you saw, nothing inside the comment form is actually evaluated. So we need to evaluate this. And this playground instruction says evaluate the top level forms in the comment form one by one. So let's do that. Option+Enter. Evaluate the top level form. Now original path is defined as the string asset/kitten.png. So if we evaluate now, Ctrl+Enter on original path, then we see that it evaluates to that string. And we want this article meta as well to be defined as this map. And if we press Ctrl+Enter on this, get the same syntax error because we haven't evaluated this yet. Evaluate top level form, and now it will be defined and evaluates to that map. And this map is the map of text that we overlay on the image. So it has a title, it has an author, it has a description. And now we can evaluate this form. So if I evaluate this form, this will first create an image from this original path. It will scale it to 1200 in width. And this image is a square image that is pretty big, but now it's a square image that is 1200 times 1200 because it scales it because we pass nil as the second dimension here. And then it is cropped to this height, 675. So this will create an image that is 1200 in width and 675 in height. And the way this crop works is that we crop the 675 pixels in height. We select the middle part of the image because that's often the most interesting of an image. And then we add the texts to it, and then we save it. And we just replace the original path extension and add Twitter.jpg on it. So we actually have this file out here. So this is what we created. So I will place that here. And so we can see here that this is, and to convince ourselves that we are actually working with this image, we could we could crop it to a much smaller height, 375 for instance. So this is the image we are working with. And we can also validate the texts, new text here. So we add x/Twitter to the title, evaluate this. The new have a new version of this article meta which is being used here, and we can evaluate this, and the image will be updated. And the way here is where we're using membrane then to do it. And let's see, we can start from the beginning. So we are starting with using the membrane UI image function, giving it a path and this scaling. So this scaling is optional. If you don't give it, the image will that will be created will be the original image with its original dimensions, but you can scale it here. So that happens there, and we can prove that if we want by not evaluating the other things in this thread. So now we will be reading this image and then saving it. So if we run the top level form here, now, so this is what happened. The only thing that has happened to this now is that it has been cropped to 1200 by 1200, or cropped scale to 1200 by 1200. Now we want to crop it and keep the middle part of it. So I will uncomment that and run it. So now it's cropped. We have kept the middle vertically. And now we add the texts here. And so that's the pipeline that we're going through to create this image. We can have a look at the crop to height here. So we are just checking here if the height we really need to crop it. And if so, we use the scissor view here to translate ourselves to the middle of this image and cropping it to the width we have and the target height. So you can look at the documentation for this, but that's what's happening there. If we have an image that is lower, is that what you say? Lower than 655 here, we instead pad it so that we will end up with an image that is 1200 and 655. We pad it with just some blackness below the image. Okay, and add text here. It returns a view that has the element that is sent in, and that is that's this image here without the texts, and then adds the overlay. So that's the image is a composition of the element and the overlay, and the overlay is created here. We create text overlay, and we calculate a few things here, but we have a padding of 30 vertically and the padding of 20. 30 is important because that's about where Twitter will add a site badge to this image, and they will add it somewhere here, which is why we place the image overlay with some margin from the bottom so that the badge will not overlay our overlay. And this is returning a view which has a filled rectangle which is transparent, and you can experiment with what transparency is good, but we're using a 50% transparency opacity here. And the rectangle is the width of the image and the rectangle height. And here's a cool thing, a very good thing about Membrane, is that all the elements that you create, you can measure them very easily, because these text could be, the overlay could be differently in height. Because now this text description here is taking two rows, right? But a shorter description will take just one row. And a longer title will take 2 rows and stuff like that. So you never know how high this overlay will be. So we measure it here with UI height of the text that is created here. So create text here is using, this is why we're using the Skia backend of Membrane, because it has this very good typography support. So we're creating this text here. This is the text style that is we're using for all of these, but then for some of these we are merging in some difference. So for the title we are merging in a font style of bold, and for the author we are merging in a font style of italic, and for the paragraph it's just this base style, which is white color. Try these font families in order, and font size 42. This is very hard coded in here, and obviously just something I have experimented with to get it to be good enough. Because this image is, when it's presented on mobile phones, it gets very small. So then the images, the text for the text still to be readable, it needs to be of some size here. And we have a spacer here in between the text, otherwise we get a bit crammed of the gaps between them. So yes, now yeah, that is what is going on in this image. And another thing to consider here is the quality of the produced image. There's a trade-off here between file size and quality of the image. So we're using JPEG, which is a lossy compression format, which produces very small file sizes for almost invisible compression. So, but you can make it visible by having a quality of 1 here. You see that we have completely, here we have no compression, and then the file is 0.5 megabyte, which is very big, and you want it to be smaller. But 80 is no visible difference, to me at least, and it is 120. To figure out where this trade-off should be, you can change here to PNG, and we change here as well to PNG to create another file. And now this compression level is not relevant, because PNG is not lossy. So now we have produced an image that is not compressed, and it's PNG. So this image, I will place it here, and I will place this one here, and place that one there, hide that. Yeah, so something like this. So this is the original image, this is our compressed image, and then you can go back here to JPEG, and we produce, say, 1 again, and you see, okay, this trade-off is not good. This image is 11 kilobytes, but it's yeah, very bad. So we will find maybe that 70 is good, and you will compare these two and see, okay, this is fine actually, but then this image is 100 kilobytes, which is fine. Yeah, so that's what you can do. So this is pretty fast feedback, right? We can change things about this, like say we try with a font size of 32 instead. We can reevaluate this thing here and then run this form again. Now you see it's smaller. This looks good, but it won't on a phone. So I will go back to 42 here. 42 is a good number for many reasons. Anyway, so you get pretty fast feedback there, but maybe not enough of fastness when you're actually working with the composition and want to see stuff happen. You need to find this comment form and reevaluate and navigate around and get the. So we are using membrane, and we can use that to give us this feedback, because membrane is this UI library, right? So you can actually write UI applications with it. So we can write ourselves, create ourselves. I will put this here again. So we can create ourselves a small dev app. And that's what we do here. And never mind this one for now. This is the app. It has this wrap errors, which if there is some error in our code, we will see that in the view. And then we also have this aspect fill here for this app, because I want to be able to resize it, because I have a small laptop screen and need to fit stuff on it. And you will recognize this because it is the same as we have here, the same thread as we have here, except we don't do this save there. Actually, I've commented away the save here because it slows down the app. But I will show you, if I remember, I will show you a use for this. Anyway, this instruction up here says in Playground you can evaluate the top level forms in the comment form one by one. So this do comment form is actually running and defining all these and ending with evaluating this SKI run, so we run the app for us. So Option+Enter, Alt+Enter here should create this app for us. Let's try it. Alt+Enter. And there, the app started. So here you see this scaling that I mentioned. Maybe I can have it like that. And then I need to, so something like that. And then we don't need this kitten here for now. Now we could work with this. And the difference here is that before I needed, when I had say updated the font size, let's try that again. I needed to then evaluate this form that wrote us a new image. But now if we update the font size here and evaluate this create text function, it immediately updates the app there. So this is fast feedback. This is interactive programming. And another thing that makes this really interactive programming is that you can inspect the application as it is running. So this function is called here with the maps, which has with title, author, and description here. And if we want to check what's in there, we can do an inline depth here of width to this value. We can't evaluate this because it's not a namespace variable. But if we evaluate this function now, when it is run, it will evaluate this namespace variable to the local one. So now if we evaluate width here, we will have it. So this is also very, very good for inspecting the app and let's see here if we could use it for something. Yeah, I don't know. We could no, let's do something now instead. So this is a YouTube video, and YouTube videos should have nice thumbnails. I'm thinking this looks a bit like a YouTube thumbnail. It's very cool. It has a nice, very cute and angry kitten. So we could use that as a but then we would need larger font for the title there. So let's make that larger. So we have the text style here, and I will then say that this header here should actually have a font size of, say, 144. Well, that was very big. So let's redefine the texts here then. Interactive programming is what I want. And I want to say powered, like this, coding fun, powered by Clojure and membrane. I don't think we need another. So if we define this, it's starting to look like that. And also another thing about YouTube thumbnails is that it's good if they are, I think it's 1960 times 1080, I think is. So that happened here. It's starting to look like a YouTube thumbnail, I think. This is still too small there, so we don't need these two here, and we want then the regular font size could be 72 maybe. Yeah, let's yeah, this is about Clojure, so we could add a Clojure logo as well to it, I think. So let's look at the pipeline where we do this. We add texts, we crop it, and then we add text. We could say that before we add text, we could add a logo. Say we want to add a Clojure. I have it here. Clojure PG. I think this should work. Yeah. And add logo. We might want to place this logo. So say we want to place it 50 from the left and 50 from the top. Yeah, let's start with that. This it has a red squiggle. This function doesn't exist yet, so we need to create it. We can look at the add texts here for inspirations. So it returns this thing with the element and then the overlay. We want to do something very similar. The element and then the logo on top of that. So we do a similar function here. Add the logo, and it had the path first, and then it had the offset X. Let's just call it X, and then Y, I think that was it. And then the last thing that comes in from this thread last here is the element that we are working with. So that will be placed here in this call. So that's the element we have there. So now we want to return a thing that has element and then the logo. But we need to create the logo. So that's UI image with path. So this should actually create this composition with. Let's see what happens if we evaluate this and then evaluate a new definition of this app. Ctrl+Enter here, and the logo is there. But we are not using the offsets there. So XY is not used here. So we want to use them, and we use them to translate this drawable, and we translate it to X and Y. And now if we evaluate this, the logo jumps to the right place. And we could also do this aspect scaling and stuff too, but it is actually, to me, very good size. So I won't do that. I will instead just close this video off. And before I do that, I want this debug image that we're talking about. We're not recommended to do it because this, I'm on my laptop, and it could be sometimes be a bit hard to have room for this, and I can't show this Java application inside VS Code. So I do like this. We have defined this debug image here as a temporary file. So if we evaluate this, we have the path to it here, and we can open that one in code, and it's not created yet, so that's why we have this error there. But we can, so we still have the output here. If we now uncomment this and redefine this application, Ctrl+Enter. Now, every time we change something in the app, it will write this file. So then now I can look at the result in there. It works for this particular application that I'm doing, because I don't have any interactive UI stuff inside that. If you were using it, doing a UI app, you wouldn't do this. And I would really recommend doing it anyway, because it gets a bit unstable actually, and it's very slow. So now it's really hard to resize this, because yeah, every little update here is writing this file. But we can do it for now just to show you the technique. And now if I have the full page here, we can look at the image in here. So interactive programming. So you see that we can work with it as interactive as we could with the app, even though it's much slower and not recommended. But we are pragmatic people, so we do stuff like that. That was what I want to show you. This is what I call interactive programming, changing the application as it is running. We haven't restarted this application once when we've been doing this. And imagine this being a much more complex application. Why not a membrane application that does a lot of cool things, and it has a lot of use and stuff like that. You don't want to restart it every time you have changed some tiny bit, or you have just nudged a logo or whatever to be a few pixels to the right or left. You just want to see it happen. And some behavior, same thing, you might have changed some behavior in the app and you just want to apply the behavior on the running app without restarting it. And you also want to be able to inspect the application that is running. What is the value of this variable coming here? What do we have in the application database right now? Stuff like that. You want to look at that while the application is running and always be able to find the truth about the application. That is the fun way to do coding, I would say, interactive programming. I hope you tried. And another thing I hope you will do is visit our sponsors. No, just kidding. No, I want you to like this video if you liked it. And if you liked it, you might also consider subscribing to the channel. I want to have lots of subscribers, so please subscribe. Please send this video around and to people you think should be enlightened about interactive programming. That was all I want to have for now. Thanks for watching. I really appreciate it. Bye.